So on this first sample, all right, so if we're talking about CBS, we're talking about like the television station CBS. What country does CBS serve? America. All right, so it is saying a CBS poll of 808 people, we're going to assume it's random, claims that 45% of people believe in ghosts. So, it's not an opinion. This is just an example. All right, Jacob. On this one, all right, our sample size is 808, and you can actually just include that it's an SRS. We're going to assume that on this one. I had it on my paper and I just didn't write it down. So we need to see, just based on this, does the data that we collect from the 808 people, does it work? Can we assume any data that we collect from this sample to be approximately normal so we can make some assumptions about an overall population? So first of all, is it an SRS? All right, so that one checks off. It's a simple random sample. Now we have to look at the sample size. What's our sample size here? All right, we need to know, is our sample size less than 10% of the population? So is our sample size less than or equal to 10% of the population? All right, that's 808. All right, how do I get the population by itself? Do I multiply or divide that over? All right, so you're always going to take the sample size and divide it by 0.1 or 0.10. What do you get? Calculators can be out. What do you get when you divide 808 by 0.10?
I don't get a calculator for this.
It's just times 10. Divide by 1/10 is times 10. All right, so in this case, our population is the United States. Do you think that 8,080 is less than the overall population of the United States? Okay, all right, it's good. We know that population, our sample size is less than 10% of the population. We're good to go. All right, now this is our last part. We have successes and we have failures. So in this case, our successes are the percentage or the proportion of people that believe in ghosts. So if 45% of people believe in ghosts, what's our probability of a success? 0.45. What's the probability of a failure? They don't believe in ghosts. 55. All right, so do you guys remember the day that I told you that like Annie had a certain percentage on a quiz and I was like, what's the number you expect her to get right? And we took the number of questions times her p-value and got a number. So what we're going to do here, your successes is always n times p, your failures is always n times q. So for our successes, the probability is 0.45 times the sample size, 808, is n times p greater than 10. What do you guys think? 808 people times 0.45, is that going to be bigger than 10? (45% of 808? It's way bigger than 10, right? What is it?
363.6.
All right, 363.6. We know that's bigger than 10. So do you guys think that failures is going to be bigger than 10 as well? If 45% is bigger than 10, do you think 55% is bigger than 10? So do you really have to show your work on that part? If you're going to say you can. We can say 808 times Q is greater than or equal to 10, and you can say yes. So all three can never met, so this is a good sample. We would say, yes, we can assume that whatever data we collect is going to be symmetric here. It's going to be normal. So yes, this one is approximately normal. Yeah, so we would always say approximate because in stats, we never want to be certain. It's not perfectly symmetric, but it's going to be symmetric enough for us to assume some stuff about the data. So all we're doing today is checking for those conditions. Simple random sample, 10% of the population, and then our successes and failures. That's not too bad, is it? We're just checking for those conditions, and then tomorrow we'll find like mean and standard deviation and go through those formulas. All right, so you guys are going to need your graphing calculator, so if you guys want to get those out, let's do that now, because I see some of you don't have those out. Now say, do I have any lefties in here besides Annalie? I'm not, you're not lefty? Really not? No. Carly's a lefty. Is that it? Is Josie left-handed?
She could, maybe.
I think she might.
I'll text her and ask.
Yeah, I need to know, because I could have swore it was you.
You just said that, I was like, how did I never know that?
So on this one, it says 13% of the population is left-handed. And we're going to do an auditorium with 200 seats, or it says an auditorium with 200 seats is built with 50 lefty seats. Now, you guys have to notice in this room, all of the desks are just a universal, like it's not a lefty or a righty desk. But do you guys know what kind of desks I'm talking about with like the lefty and the righty, like it's got the elbow arm thing? All right, so I will tell you guys, in college, most auditoriums are built with like a little desk thing that can fold down because they give exams in big auditoriums, so then you can put your lap seats up. And it is quite comical. One of my part-time jobs in college was to administer math tests at Purdue, and I was like the calculator police. And whenever I would go through, it was so funny watching people try to find lefty seats when they were left-handed. They would walk down and they'd be like, they would look and they would go up to people and be like, "Are you left-handed?" And they'd be like, "No," and they're like, "I want that seat." And I was like, it was quite comical, but you know,
You
most
seen
of the
Good Will
left.
Hunting?
It's been a long time.
That movie's awesome.
Does that have something to do with lefty seats?
No, just the college thing.
Oh.
I don't know, I just thought of it. It's a good
Josie is
movie.
left-handed, by the way.
Okay. I'm not crazy. Hey.
Not about that anymore.
All right, so on this one, we're just going to say a class of 90 students enters, and they're going to know, will there be enough seats for all the left-handed students? Now, I put a little asterisk by that because we'll eventually solve the question, is there enough seats? But today I just want to know, is this data good enough to make assumptions, I guess? So if you look at this, what's our sample size? Okay, we've got 200 seats. But whenever we are doing the sample, it's actually the 90 students. Because the only seats that are going to be assessed are the 90 seats that people sit in. The
Okay.
other seats won't be, but we just want to know, that's the sample.
Can we just look at this and say, yes, there's enough lefty seats without doing any work?
Well, here's the thing, can we assume that this is normal? All right, so this is our sample size. All right, so do you think just a random class going in can assume it's random? Do you think that they're not gonna have a specific class for left-handers, right? Like, it's gonna be a random selection of kids. So on this one, we can assume that this is random. Like, they're not gonna have like calculus for left-handed people and calculus for right-handed people. That doesn't exist. So a random class that's assigned is going to be a random selection. All right, now let's talk about this 10% of the overall population. Do you guys think that 90 divided by 0.1 is less than the overall population of people?
Yes.
definitely. Because this is 900. Because the overall population, it's just saying 13% of the population is left-handed. We're just talking about everybody. There's definitely more than 900 people in the world. So this one meets the 10% condition. Now the successes and failures here. What's the probability of success?
Seven.
Well, what's the probability? What's the?
Oh, that they're left-handed?
Yeah,
Oh, yeah.
13%, so what's my P? 0.13. So, what is 0.13 times 90? What is the expected number of successes there? 0.13 times 90. 11.7, is that more than 10? That works. All right, now your Q would be the opposite of this, which is 0.87, right? Is that gonna be bigger than 10? 87% of 90? You know, so that's greater than 10, so that works. So this one, we can assume that it's approximately normal. Now, Jacob, you think that there's going to be enough seats?
Yeah.
I'm gonna say, we'll talk about that later in the week.
Why, am I gonna be wrong
I don't
later in the
know.
week or something?
No, I just wanted you to know, I'll answer your question later, but today we just are looking at conditions. All right, so this is our last one that we're going to do together, so I'll give you guys some time to talk about the M&Ms. If we hadn't had 2 weeks of snow days, we probably would have done this entire thing in person, but we just didn't have the time. We don't have a day to sit and count M&Ms and make a chart and. We might have some time after spring break, but not right now. 14 more school days, everybody.
Oh, spring break.
Mhm.
Well, I have baseball practice every single day of spring break for 3 hours, so
Yep,
that's super exciting
Mhm.
for me.
I'm camping.
I have literally nothing to do. My parents are going out of town on vacation, my sister is going out of town on vacation.
If you guys wanna drive by.
I'm just thinking the full week after spring break.
Oh, because your mom's spring break's different, isn't it?
Yeah, and my sister's getting married, so we're doing
Baby,
baby.
why is there a boy calendar?
I get all my things except for one tomorrow, and then goats are on Sunday.
I have a tiny couple of that, look at that.
Yeah, say we're camping at Shakamak. And then at the end of spring break, we'll take the camper to the lake, since we're not going on our 2-week road trip now.
Wait, what?
Zach got stuck in Vegas. He lost vacation days. We don't have enough time to go.
That was so fun.
That sucks.
He fell on his bike and like broke his.
My husband got stuck in Vegas during all the, he had a connecting flight through Texas during all the snow days.
So I was like, Tanner, you're fine.
We went to Vegas for a wedding and flew separate. I made it, he didn't.
And Kurt goes, dude, you're lying. I grabbed his wrist and he yanked his arm away from his head. He even got an X-ray collar.
All right. Okay, so for this M&M example, can we assume that M&Ms are randomized in a bag when they bag the M&Ms?
Yeah.
All right, so this one probably is going to check out. Now, in this next set, what's our sample size? All right, our sample size are bags of 50. So our sample size is 50. Is 50 divided by 10% less than all M&Ms? We can assume that there's more than 500 M&Ms in the world, right? All right, so that checks out. Now let's talk about successes and failures. A success means we're going to get a green M&M. A failure means we're going to get something else. So what is our value of P? What's the probability of success? 0.1. What's the probability of a failure? All right. What's 10% of 50? Our sample size times 0.1, what is that? guys, this is not, like, you can use your calculator, but this
Five.
should not be a trick question. What is it?
5.
5. All right, how many failures do we expect to see? All right, so what this is telling us, in a standard bag of M&Ms, if we all had our own bag of M&Ms, on average, we would expect to see in each bag 5 greens and 45 not greens. But does this meet the at least 10 successes and 10 failures? All right, it has more than 10 failures, but it has less than 10 successes. So on this one, this is not approximately normal. When we don't have the 10 successes and 10 failures, it's skewed. Are you guys ready to draw a curve? All right, so I want you guys to know this is good, but this is bad. Our failures are less than what we are expecting it to be. So whenever it's normal, we expect the probability of success to be in the middle. Now, in this case, we have a low number of successes, right? So for this example, our value of success is actually a little bit lower than what we expect it to be. So this is skewed. So really, the graph, we want it to look like this, but the graph actually looks like this. Do you guys remember if that's skewed left or skewed right? All right, how do we know it's skewed right?
Because it's shaped like a foot.
All right, it's shaped like a foot, and if we can see which side has more data on it.
Right side.
The right side has more data. So this is skewed right. So whenever you might be asked today on your assignment if it's skewed, which way it's skewed. So whenever you expect it to be in the middle, but if it's less than, the curve's going to be like this, and you guys just remember, I almost wore different shoes today, but then I remembered to put slip-ons on. All right, so on this one, it goes bigger on the top, it goes down, that's my right shoe. If it's bigger on this side and then goes down to the left, it's your left shoe. So you just kind of look, does it look more like your right shoe or your left shoe? And that'll help you decide if it's skewed left or skewed right. So this one, since it is skewed, this is not approximately normal. Normal would mean that we can assume it's almost symmetric. This one, it's skewed. So if you guys think you're ready to tackle one of these on your own. All right, I want you guys to try this next problem by yourself. Feel free to discuss it with people next to you. It's got to meet all 3 conditions for it to be normal. So it says the state police believes that 70% of drivers speed on the interstate, and they plan to research by setting a speed trap and assessing 80 cars. How many of you guys feel like you would fail this speed trap?
Me.
I don't necessarily like the speed. I just like to be first. I know that this is, so if there is no one in front of me, I don't really care if I'm driving the speed limit or not. But if there's somebody in front of me, like I've got to pass them. I don't know. It's like a control thing. Like I don't like to follow people. It makes me nervous. I like to be first.
They'll probably, on our way to 70 to 75 the whole way to town.
I'm good at it too.
You don't even slow down in Shelburne. What's wrong with you?
No, I also.
No, I don't.
No,
slow
I
down.
said like I slow down to
Like,
like
do you guys
60.
not know at the Shelburne Baptist Church, there's like always cops there ready to trap people.
I've
I've
never
pulled over
over
it.
I
so-
said I cruise at 70 miles per hour and keep going. Don't stop.
Hey, I will tell you what, I don't know which cop it was, but whenever the school plowed the parking lots, there was a cop and it was like the most genius thing ever. So whenever they were out here, you know, like they plowed the sack and like they just pushed them and made those mounds. There was a cop that was sitting right across the road from Joe's in the sack parking lot, but they were hidden by this gigantic snow mound, just sitting there and getting people on Section Street.
It was probably Ryan. Ryan always sits in the
It
second.
was an
parking lot.
SUV. I thought
Yeah,
it
Ryan
was.
drives SUV now. Was it all
Since
black?
when?
I don't know.
Yeah, it
since-
wasn't all black SUV. I bet it was Ryan.
I tried to go the speed limit on Section Street, and there was always someone right on my butt, like honking, like go faster. It's like I'm just
Yeah, I hate
follow
that.
the
I was
rules.
driving down Section Street. I was probably going 40, and there was a cop like right on my butt, not pulling me over, and they like, I don't know, but I was like, should I speed up? Because they were like riding my butt.
One time there was a cop riding my butt all the way home from the school, and like they didn't use
Alright.
their turn signals.
Are you, hey, can you work and talk?
Yeah.
Or multitasking.
I know
I
some of you can, but I don't know if some of you can.
I
Like,
know.
some of you can, some of you
They can't,
cannot.
'cause they can't pull you over outside of city limits.
Lexi, can you really not see back here?
Well, I can't, but
Okay.
I don't think it's a comfort thing. I like having it in case I write it down.
That's fine. Just wait.
Wait, what?
Alright, what do you guys think about this one? Do you guys think that a speed trap, just the first 80 cars that go by is random enough?
Yeah.
Alright, we have no idea what kind of cars in those 80 are going to come up. It's random enough. Alright, now, what's 80 divided by 0.1? Alright, do you think that 800 is less than the overall population of interstate drivers? Definitely. Alright, now, the 10 successes and the 10 failures. Alright, the probability of success is we got 70%. So, our successes, what's 80 times 0.7? 56, that's more than 10. Alright, now what about 80 failures? 24 failures is what we would expect. So what that's saying is, if they did a speed trap for 80 cars, they're expecting around 56 people speeding and 24 people not. Everything meets, so the data that they're collecting there, they're assuming is approximately normal, so we're good to go. Now, this one is not approximately normal, and I want you to tell me what part makes it fail.
There's not enough failures.
You don't think there's enough failures, okay. So, show me the work
Wait, on this one or?
on the next one. So I'm telling, yeah, the speed is good. I'm telling you the bank one is not approximately normal, but I wanna know what part makes it not work. is random enough? No.
Okay, sorry.
Alright, so, does it tell us what type of loans, or it's just the last 30 loans? We don't know if it's a mortgage, we don't know if it's a car loan, we don't know if it's a farm loan, a business loan, we don't know. We just know it's 30 loans, we can assume it's random. Now, what about the 10%? Do we assume that 30 divided by 0.1 is less than all bank loans? Do we assume there's more than 300 bank loans?
Yeah.
Yeah, that's good. Now, how many successes do we expect to have? What's 93% of 30?
27.9.
All right, 27.9 successes, that's good. Now, what about failures?
2.1.
That's not less than 10, this is wrong. So, we normally, we like the probability of success to be in the middle, and we have our little bell curve. In this case, we have lots of successes, not as many failures. So we're expecting the number of successes to be about here. So is this skewed left or skewed right? And there we have it. You guys think you could answer maybe 4 or 5 of them on your own? All right, so this week we are breaking it up into small chunks. You guys have like, I can't remember if it's 4 or 5 on Khan Academy. And that is your, so every day we're adding a little bit. So I do want to give you guys just, where am I at? Wrong class. All right. So I know that this isn't your favorite, but it is what it is. Because the textbook does not match the order I like to do things. I made this mistake last year by grouping it all together. The year before, I did it like this and I liked it. Last year, I tried to go by the book and I didn't like it. So I'm going back to what worked. So we are, this week, every day, we're adding something. So today we checked for normal conditions. Tomorrow we're going to do the formula for mean and standard deviation. Then on Wednesday, we're going to find probabilities. Like once we have the curves, we're going to do like normal PDFs and CDFs. I'll make a video for you guys to watch. And then we're going to learn on Thursday how to do a Z-table. So do you guys see the first 3 days, they're due March 5th. When's March 5th? Friday. All right, so your first 3 are due Friday. Then Thursdays are then due on the 8th, which is the following Monday. So remember, Khan Academies, you guys can do those as many times as you would like. So if you don't like your grade the first time, try it again until you get the score you like. You guys will have time to ask questions on the other on the assignments as we go throughout the week. So if I were you guys in this next 7 minutes, I would try to get some of this done. Like I would try to get today's done. Yes.
I'm not going to be here all week next week.
Yep.
Just a
And
heads up.
yeah, so I plan on recording
Okay.
and
Will it be easy to, like, will it just be like this kind of stuff?
yeah.
What?
And I'll be on Thursday and Friday of this week, so will you record those too?
Yep.
And then,
What'd you say?
Okay.
Okay. Hey guys, normal means it's a bell curve. Do you guys remember what uniform means?
When it's the straight line.
It's just like a straight line across. It's not going to be uniform. It's either going to be normal, skewed left, or skewed right. Uniforms just kind of want to throw you off.
Oh, last year I did it. Oh, I haven't done it.
What do you have to say? Oh, is it for airlines or something?
yeah, take my head, all my teachers have one. Silly goose.
Sorry.
We have to give you a temporary on.
record live, so the videos will be up by 1:30 our time. Where are you guys?
I'm just gonna be like,
Oh, okay.
so.
I didn't know if you guys were the same time or an hour behind.
No, right. There's a lot of fun.
You walk a mile out into the ocean, and you're still in a foot deep of water.
I don't like to
That's
go
the worst.
swim.
You're walking on broken
So-
seashells.